So with this procedural bridge, again, feel free to ask questions. I'm going to see it in the chat as I go through. Ultimately, the way that we want to think about this is it's a procedural bridge, and we want to think about it in a procedural sort of way. So how can we break down this bridge into smaller components that we can then work systematically through? It's like, where are things the same? And, where are things duplicated? Where do we actually have to have unique things? So ultimately, we can break this down into three sorts of objects that we're going to be working with inside. First is going to be our support beams right here. Next is going to be our bridge piece right here. And then next is going to be our rail piece right here. So we can start with one and kind of construct our way through it. And things in one might drive things in another one. So it's really kind of neat how this all kind of talks together so that it all works. And the first thing I do want to, let's see, the first thing we're going to do in here is we're going to work with creating our supports, because the supports it's an easy way to start. It's going to help drive some other characteristics of our bridge, such as like we're going to use them to help with doing like our length and our some height stuff. So it's just an easy way to do that. So I'm going to first in my Houdini setup, I'm going to first go to my front view. Let's see. Oops, set view to front. Let's make sure that I am saying the correct. It's not top. I'm just double checking. Yes, I'm going to go to my front view, and I'm going to be using this curve tool to begin this whole process. And I do want to build this on my grid just to make my life easier. The curve tool is a little bit weird to get used to, so we do kind of want to make sure that we are just creating it correctly at first. So I am going to actually turn on my grid snap right here, grid snapping, so that as I draw my curve, I'm going to be able to snap it to grid points to just make it really easy. So I'm going to click curve right here, and it's going to add a curve object, which is fine. And I'm just going to start to create this. And if I remember correctly, let's see. I'm actually going to start here. I'm going to start with the bottom. And I'm going to make it, let's see, probably about this shape. You don't have to be as exact, you don't have to do it exactly the same as me. But I kind of already have like a pre-planned out. So that's half. Go over, down, over, down to here. And I'm going to hit escape. And this is going to be the silhouette of my curve. Let's see here. Okay, sorry. So I have the silhouette, and this is going to be what we're going to base our thing on. So once we're done with this, I'm actually going to rename this. Rather than curve object, this is going to actually be the whole bridge piece. It's just a little bit easier to start with the curve object as your first geometry so we can easily place it. But I'm going to end up renaming this to procedural bridge. And I can switch this back from front view to perspective. And I'm going to just double click on procedural bridge to go inside of this and get to the guts of this, of what I'm actually going to be working with. So, okay. So curve one, I want to rename this. We should start to try to be a little bit better with keeping this stuff kind of clean. So it's going to be a little bit more complex of a node system this time. So it would be, you know, we want to be able to find things if we need to. So I'm going to actually rename this to curve support profile, since that's going to be our profile. And before I get too far, I have kind of planned out everything that I want to be able to adjust. And, you know, those are like things like those sliders in that main one where I can do the length, width, and height and everything. And I'm going to actually set those up first before I do anything else. Now that I'm kind of like, I have my base, I'm inside of here, I want to set up all of my adjustables that I'm going to be referencing somewhere in my graph later. And we do this by creating our null object. We kind of did this a little bit last week, and we just then go into our null, and we're going to set some parameters. We're going to make a parameter interface and set those. So I'm going to, in here, kind of like up here at the top, I want to be able to see it. I'm just going to find a null node, and I'm going to rename that. Null1 doesn't really tell me anything. I'm just going to name it C for like control or something like that. It'll just be easier to find later. We're going to call this C. So I'm going to go through, and I'm just going to make all of my parameters that I need. So to do that, I'm going to select it. It's up here. I'm going to go to the gear. I'm going to say edit parameter interface. I don't need to see these things in here, so I'm just going to select them. I'm going to make them invisible. So some things that I need to work with, I'm going to want to do a length and a width. You know, those are two very easy ones. We want to be able to adjust the length and the width of our bridge. So I'm going to use a float for those versus an integer, just so that we, you know, there's no real reason to use an integer. Might as well use a float. So I'm going to put in a float, 2 floats, and I'm going to come in and rename them. So the first one is going to be my length, which the name is just going to be lowercase l length. And I'm going to give it a label of length. There's no reason to change the name of that. For all of these as well, we do want to make sure that we go in and we set the ranges. Since it's something like a bridge, the length should never be something like 0, because it really wouldn't make any sense to have a 0 length bridge. So we can come down here and set that range. I'm going to say maybe the minimum length, which would make sense for our bridge, is going to be a length of 2. And I'm going to lock it so that we can't go past 2. For the maximum, I'm going to put something maybe just like a 50, but I'm going to leave it unlocked. This means that a user could potentially go past 50, but they could go in and type it in. But this one means it can never go smaller than 50. But our little slider will be from 2 to 50. I'm going to make sure I apply that. The next one will be our width. So the name of this is going to be width. Remember, these names, they're kind of like variable names. So it's very important to make sure that we know what we're naming these. This one will have a label of width. That's a pretty easy one. As far as the range for this one, I'm also going to probably lock it at a range of 2, but maybe have the upper range for the width of the bridge be something like 20. The next thing I do want to adjust is the height of our support beams, of our support columns. We're going to build a minimum height, so that's not, you know, a big deal, but, you know, we can make them taller. But the way that we're going to construct this, it's going to be another float, is 0 will just mean the base height, and anything higher will just pull it up from that base height. So this one will just be support underscore height for the name, but the label will just be support height. The range will lock it at 0 and 10, whatever, that's fine. Not too concerned about this one. The other one we want to do next is we want to control how many columns appear on our bridge. And since this is going to be a very specific number, we can't have like 2 3/4 of a column. We're going to use an integer. So I'm just going to drag an integer over. The name of this parameter will be column num. Column underscore num, but the label, we can be a little bit more descriptive. It's just going to be number of columns. This one, we do also want to make sure we set a range because we can't have no columns. We need to have at least 2 columns, so we have 1 on each side. So we're going to lock that at 2, but 10, whatever, it's fine. The other thing we do want to control is the road height. We want to be able to make a thicker road if we need to. So we will put this one as a float as well. So I'll drop that in. This one's just going to be road underscore height with road height. I'm going to lock this in with the range of a minimum of 0.25 because we don't ever want to have no road, but we're going to lock this in with a minimum of, like, that's as small as the road can ever possibly get. Height of 10, that's fine. Don't care. We also are going to want to be able to control our rail supports. And the way that we're going to do this, and like this probably doesn't mean anything to you now, but when we get to there, it will. We're going to have a float for called rail support scale. Rail support scale, because we're actually going to control the thickness and thinness of our rail through a scale rather than like changing some numbers. But we'll call this rail support thickness. That makes more sense to if you see it on your slider what that is. This one, the range will be locked at 1 because we're going to use it as a scale. So we want to keep it as the minimum as a scale of 1. So we'll do that. And let's see, we also need rail support height. So we'll add another float. Call this rail underscore height. This will be rail height. And this one, does this one have a, we'll keep it a minimum locked in at 1 so you can't have like really super teeny tiny ones. And the last one is going to be rail frequency, which is how many rails do we actually want along the length of our rail. So this one would be then a float. I'm sorry, not a float, an integer. Again, I realize some of this might not mean too much, but like I kind of designed this already and I know exactly what I'm going to need in here. It's nice to kind of get these out of the way so as we build our stuff, we can easily go in and reference all of these parameters. So we're not going in and just, oh, let's make a new one, let's make a new one. So it'll kind of flow a little bit easier. So even if this doesn't quite mean anything to you yet, this is going to be rail underscore freak. It'll be nice to have these all completed so that we'll be able to just kind of go through our nodes without having to worry about this. The range for this one, we'll just do a minimum of 1 and that'll be good. Okay. I'm going to hit apply for all of those and these should be all good to go. And that's all we're going to need for our demo. I'm going to click accept. So now if I go to the C, we have all of these ready to go. Length, width, support height, number of columns, road height, rail support thickness, rail height, and rail frequency. And that's just being stored in this C null node. And this is going to be what drives all of our stuff. All right, so now that we have that out of the way, I know we have like our little profile, we kind of jumped to that. Now it's going to be a little bit easier for us to kind of work now that we got that out of the way. So the first thing we're going to set up in here is that whole idea of being able to change the height of the support. And we want to do this, we don't really want to do this where we just scale the object, because if we do a scale on this, like if I were to put a transform node in here and hook this up and we're just like, hey, let's just scale this. What's the one? Oh, oops, nope, that's not right. Oh, I don't remember how to use a little slider. We'll just, no, not keyframing. I did something. Sorry. If we scale this like a 6, it's deforming the whole thing. And it doesn't look like it got taller. It looks like we stretched it out. So this really isn't the way that we want to do this. Instead, what we want to do is we want to just move these top vertices upwards, which is like if we were doing a 3D model, that's how we would do it. If we needed to make this taller without like making it weird, we'd just go in, select our verts, and just move them upwards. And we're going to do the same thing in Houdini as well. This is very similar to how we did things in the Maya tools, where we had to, if we wanted to manipulate vertices, we wanted to manipulate faces, we made those lists of verts, those lists of faces, and then we could use, we used looping possibly, or, some other things to manipulate those. In Houdini, though, instead of making lists of things, we make groups of things. So before we can move those, we'll need to make a group of the vertices that we want to manipulate. And we do that with a group node. And the nice thing about making these groups is once we make them, we could call them other places in our node system. So like we make it once and then we can use it later if we need to. So I'm just going to make a group. Let's see, which one is it? Group. And connect this up. And I'm going to name this one, group 1 doesn't mean anything to me. I'm going to call it top_points. And I'm just renaming the node this. I didn't name the group this. To actually name the group this, I have to come up to group name and call it top_points. I like to name the node and the group the same thing just so it's really easy to find. Notice now it says top points here as well as the node. So that is what this group is called. We're not grouping primitives. We are going to group some points. And I'm just going to we could kind of brute force this if we need to. But what we can do too, if you also want to check, is we can come over here and where it says like this number thing, we can see what our edges are numbered, our points are numbered. And notice it is based on when we placed them. So we just need to select all of these. So I'm going to get this little selection over here and I'm going to click on a point. I'm going to hold down shift and then click on all the other points I need. I think I can just press enter and notice that it now says that this base group is points 4 through 10, which is correct. So I just use that to select them, holding down shift to add. I think the control, if you accidentally select something, will take it away. But now this top, we're saying, hey, this group of vertices is called top points. And we can use this later on anywhere in our code. I'm sorry, our node system. So now that we have our group, we can now do stuff with them. What do I want to do? I want to move them. So that's just a transform. Think about if we were modeling this in Maya, we would just be selecting them and then using our move tool. Same thing here. We are going to move those groups, and we do that by saying, hey, this transform node, we actually just want to apply this to a group. And what group? The top points, because we already made that. It has this nice little drop down, so whenever we make a group, we can find it with that drop down. That's why it's really important to name this. I'm going to also rename this to transform support height just for myself, so I know exactly what this node is doing. It'll be a little bit easier maybe to find it. It's a good habit to get into of naming all these. Okay, so what do we want to do? We want to translate that group of points upwards, which is our y-axis. We can come in here and type it to see how it works. But if you remember, this is something that we want to control with our sliders. And we had gone ahead and we made all those up in C. So we want to come back to C. We're going to find that parameter that we created right here, the support height. I'm going to right click on it. I'm going to say copy parameter. So it's going to copy the idea of support height. I'm going to come back down to my transform. I know I need to transform it on the Y, so I'm going to come in here, and this is really important. I'm going to make sure that this 0 gets deleted out. So when you're doing this stuff with inside of here, these things, make sure you delete out anything that's already in there because it can mess it up. And then I'm going to right click and I'm going to paste relative references. So it's going to paste a reference, CH, that's what that means. And then see the C, that means node C. Oops, not that. And it's looking for the support height. And now if I come in here and change it on that C, on my slider, I'm getting a nice taller slider. We did set this up so this is always going to be the minimum. You could always, adjust it later, but maybe you never want a bridge that small. So 0 means this, and we're just going to then add heights to this. So we can kind of set this up however, we need to in different circumstances. So hooray, we can now change the height by our little C null up there. And so we're getting along. We got that all hooked up. We're good to go. We can make adjustments. The next part would be, if we're making this in Maya, we would take this polygon and we would just extrude it, right? That's how I would assume, we would be modeling this in Maya. Same thing in Houdini is we're going to do a poly extrude. That's what it's called, poly extrude. And to find these, I'm just right clicking and I'm starting to type poly extrude until I find it in here. Hook this up. And we're going to be doing poly extrudes multiple times. That's pretty common when you're 3D modeling. You do lots of extrudes as you're modeling. I am going to kind of go over how to set this up in this node, but in future nodes, I'm probably not going to go over all of the steps where I'm going to be very specific in it. So just know that I'm just setting this up the same way each time I do a poly extrude. It's going to be almost the same exact way. What I'm going to do with this poly extrude is I'm going to turn on, see this front transform? I'm going to transform extruded front. I'm going to turn this on. And it's going to give me these settings down here. And the next thing I'm going to do after I turn on transform extruded front is I'm going to turn on transform space from local to global. So if you start extruding things and it looks like it's not extruding in the right direction that you anticipated, probably forgot to turn it to global because we want to make sure that we're doing that this way. The other thing I'm going to turn on is I'm going to turn on output back so that it's going to be, if we don't turn it on, we're going to have holes in it. You can always turn on output front and output back if you don't want those end caps, but we do want the end caps, so I'm always going to be turning that on. So now if we start extruding it in the Z, do you see how we're getting it? I do want to make a note though, because the way that we drew the curve, it's not quite working the way that we want it to work. So we're going to have to go back and make a slight change. I wanted it to do this so that I could show you how to fix it if you do run into it. So you might not be aware of this, but do you see how it's kind of dark on the outside? And if we zoom in, it's really light on the inside. It's because it's actually flipped the wrong way. It just has to do with the way that the curve was made. If we turn on normals, let me actually turn off those numbers. It's kind of distracting, but we can, display our normals and they're all pointing inside. Like we should have these little things sticking out. So this is a way that we can tell that something's wrong with our normals. Same thing with this one. Our primitive normals we don't see them. So this is actually, it's inverted. So we do need to make sure that we fix this. This is a really easy fix. You just have to make sure that we do it. But I did want to mess it up so that if you encounter this, you know how to fix this. So I'm actually going to go all the way back to my curve support profile node over here. And we just need to come in and reverse it. Do you see this one? And once we reverse it, we just had to go the other way with what we're making for with that polygon. And now it suddenly turns light colored. We see all of our nice normals. It's going the correct way. So if it looks like this and you're like, oh no, and you realize that you kind of feel like something's going on, we just have to reverse it to fix it for that. Okay, let's go back down to here. So normals are correct this way, and let's turn that off too. And we are able to extrude. If you kind of remember though, again, we're building procedurally, we want to be able to adjust this. The extrude is actually going to be how we control the, we need this to be extruding the length that we want our bridge. Like we want these beams to support the length of our bridge. So that's going to be another thing that's controlled by our C node, that null node that we created. So rather than 5 and putting in a specific number, we need to come back up to C, and we want to make sure that we are referencing this length. Hopefully you can see why I just went ahead, no pun intended, see why. I went ahead and made all these because we're going to be coming back to this a lot, since a lot of different things in here are going to be controlled by those. So I'm going to right click on length. I'm going to copy my parameter. I'm going to come back down here to my poly extrude, and we're controlling this with that Z depth. So I need to make sure I delete out that 5. Like that's fine that I tested out, but make sure the 5 gets deleted. Then right click, and we're going to paste relative references. And once I hit enter, it should pop back down to that minimum of 2. So now I can come up here where that C is. And if I adjust the length, this is how long my bridge is going to be. So I can easily adjust that now. Maybe it's like our I-beam or something like that for our bridge. With the slider, like it's not anything that we are controlling down here. All right. Any questions so far? If you want me to kind of explain something a little bit better before we go on to the duplication with this, or is everyone pretty good? All right, I don't see questions, and that's fine. So we talked about using the null node to hold all of these parameters up here, right? So that we can reference them later. There's also another really good use of the null node, and that's to kind of use it as a way to, how to explain this? Almost like a placeholder where we can easily rename something and we know exactly where to find it so that we can reference it later. And I think the more that I work with this, the more it'll kind of make sense of why we're doing it this way. It's kind of sort of also why like we do like the grouping and we name the groups. Because what I'm actually going to do next is I'm going to put down a null node and feed that extrude into here. It doesn't do anything, but I can rename this null node from null1 to single support. So now if somewhere in my code, in my node, I need to deal with this, and I'm going to have to do that, it's going to come back later. If I need to find this particular snapshot of this model at this point in time, I can just look for single support. If you're still kind of iffy on what this means, it'll make sense once I actually use it in that. But just know that like this is another use of the null, and we're going to do this multiple times. Where it's almost kind of like an end cap of like, hey, we're done with all of that stuff. Maybe your nodes are a little bit messy up here, but ultimately, here's the single support. It's done, and we can reference it with this null later on. So that's why we're doing that. Yeah, it's kind of like a label. Like we're kind of like saying, hey, all of that, this is the last of it. It'll make your life easier to understand, and especially if you're working with other people to create things like this, they'll be able to understand what you're doing a little bit better too. Okay, You can almost think of it almost like a function. Like, hey, this function is holding all of these commands for you. This is just what, like this thingy, the subnet, or because it's
No,
not.
there's a thing under add where you select all your nodes you're gonna have in a box. It's kind of like in Unreal where you can have the little box around it.
Box. Is it like a node?
It's on the upper toolbar thing.
Oh.
Under add. To in the.
Oh, here.
Yeah. You select your thing and put it in network box.
Let me see what that looks like. Let me save this real quick. Have it saved. This is what the demo suggested to me and as a good workflow for this. There might be reasons. Maybe some people use that workflow. Maybe some people use this workflow. Let's see. Let me make sure I'm saving this in the right spot. Let me see what it does. Maybe it messes up with how things I'm going to use this for later on. Let's see. So like you select them all. Oh, like just kind of like connecting them together. Can you name these things?
Yeah.
I'm going to put a test on there and I'm going to see if what I can do later will work with that, because I don't want like this. I want the output of it. So like this is kind of like the output of all of that I'm going to be referencing later, kind of almost like an object.
Probably not.
Yeah, but you know,
probably just kind of labels it.
It is nice to do those kind of things because it does make your stuff look pretty and easy to find, and you can move stuff around. That's really handy. But yeah, we'll see. I think this is. We'll see. I'm going to see if I can find this in another spot. But I'll leave it there. So this is kind of like the output of all of those nodes. Kind of like, hey, we can mess with this specific output in a later spot. Okay. So the next step that we want to do is we want to be able to put these all down with the width of our bridge. And the way that we're going to control this is actually with a line. So, you know, we're kind of done with this for a little bit. I'm actually going to move over to here and give myself a little bit of a spot. But I'm going to drop down a line. And I'm not going to call it line 1. I'm actually just going to call this width, because that's what we're going to be controlling with this. And what we need to do in here is, if you remember, our width is actually being controlled by, let's see, by our C node up here. So rather than coming in and saying, let me turn it on so we can see it with the eyeball, rather than saying, sorry, I just want to make sure I'm got the right, putting this in the right thing. Our length should be determined by C. Like I know it's called length, but in our bridge we're actually controlling the width, so don't get confused there. So I'm going to go back up to C. I am going to come up and right click length. I'm sorry, confusing myself. Width. This is the width of our bridge. Right click, copy your parameter, go back to here. I'm going to paste that into this length. Remember, I need to delete the 1 first. Right click, paste relative reference, and it's going to be now controlled by that slider. It's going in the wrong direction. We don't want it to go up and down. So we don't want it to go in the Y. We want it to go in the X. So I'm just going to put direction for this as X is 1, Y is 0, this is 0. We also can want to control the points, because this is ultimately, you know, not just the width, but it's also going to be where our columns are on here. That's what we're going to be controlling with this. And this is controlled with C2. It's controlled by our number of columns. So I'm going to come back in here, get our copy parameter. I'm going to come back down to width, and I'm going to paste this, you know, delete out that 2, and paste our relative reference to our column num. It doesn't look like anything changed because I think we have all those defaults set that way, but we can come back to C and we can change our width. Why is that looking weird? Oh no, deselect. To, that's really weird looking. I think I messed something up. Hold on. Width. Length is right. What did I do there? Maybe it's because I have it clicked on. That's strange. Number of columns though. Fixes. Turn on my points. There we go. Number of columns. We can see it adding more points to there. Width. Don't know why that parameter is acting weird. Oh, there it goes. I gotta click it on and off. Okay, there we go. So there we go. Sorry about that. I just clicked on the name and it would let me come in and type in a number, and I just click it off to go back to the slider. So there we go. So our width, and where we want our columns to go. So line done. All we need to do now to move those columns is we need to just copy those to our points. And we used this one last time. So I'm going to keep this up here for a reason. We're actually going to come back and manipulate this in a little bit. But just for simplicity's sake, we're going to do this down here. I'm going to add a copy to points. Copy to points node, and we feed in on the left the object we want to copy, and on the right we feed in where are the points we want to copy it to. Now if I click on, we can see all of our columns are now copied to all the points on the line. Obviously this is not a really good setup. I can go back to C and those are too many columns. Or maybe the width isn't wide enough for that many columns. If you get more advanced, this is stuff that you could control, but we're not too concerned about that. Where like you could set up things in a way that you would never have weird situations like this, but hey, this is a good start with something more closer to that. So let me actually go down to 3 and I'll make this maybe closer to like a 10. That looks pretty nice. So ta-da, we're using that line where we're copying all of our supports to all those individual points. And that's controlled through C by changing the length and the points on that. So now that we have our width, the next obvious thing that we can make with this is going to be our road. So, and we can just build that off of the same one. So this is, we're going to use that for here. And next, we're just going to kind of build another road, another node off of here to build the road. So let me come back and click this back on. I'm going to use an extrude. I told you we're going to be doing this a lot. Poly extrude. I'm going to put it right here. I need to set this one up good too. So transform extruded front. I need to make sure we're outputting everything. And this one is just going to be a Y extrude because we can't, quite extrude it yet, but we can extrude it up and then we can extrude it back. I do need to set this to global. This is something that's controlled by our C. So I'm going to go back to C. I'm going to grab that road height, go back to that poly extrude and paste that into our translate in the Y. Paste relative reference, hit enter, and now we have our height. And this can be controlled by that slider now as well. Now that we have our height, we can do another poly extrude for that length. And hey, guess what? This is also controlled by our C because we did the length for our beams we can now do the same exact C to extrude it out correctly for our length of a road. So I'm going to go grab that C again. Copy our length and put it into our Z for our extrude. Ta-da! And now this road will always be the same length as our beams. So the other thing that we need to do now is, it's nice, we have this, oops, I messed it up. How do you curve these? Alt-click, just so I can move it out of the way a little bit. There we go. We're going to come back to this later. I'm going to show you what we're going to do with this. But I think I'm going to go through the demo and then we're going to come back and tweak it to make it look a little bit nicer. You're going to see in a couple minutes. That's why I'm leaving this here. So it's all good and said, but if you notice, where is that road? If we kind of jump between our copy to points and the road is at the bottom of our supports, and that's not really where roads should be. They should be on top of the supports. So we do need to move this to be on top. And the way that we do this is just like we would do if we were modeling this in Maya, is we're going to move it. So we're going to make a new transform node. Maybe I'll, I bet I was kind of bad about naming those. Maybe I'll be nice and name this one transform road up. For the sake of time, I'm not really going back in and naming all of these, but it is a good practice to get into so you can easily find these. But I don't want the video to be too long of me typing in some stuff. What do we need to transform? We don't really need to make a group because it is what it is. We just need to move the whole thing. And we need to move it so it is on top of our supports, right? So we have something that we can use. We actually used a similar kind of concept in Maya when we did the Python Maya stuff for some stuff. And what we want to do is we want to find the bounding box of our support. Do you remember bounding boxes in Python? It just kind of will tell us the maximum X, Y, and Z and the minimum X, Y, and Z. If we can find the maximum maximum Y of the support, because that is something we can control too, so we can't just type in a number. If we know what its max Y is, we can move our road to that max Y. So it's going to be all kind of controlled with this. So it's going to be really kind of cool how, even if we adjust the height, that road's going to kind of go up with it because the bounding box is going to change. And the way that we do this is we need to come into our transform node. We don't have to worry about groups for anything because it's the whole object that's getting moved. We're going to translate it in the Y. So we're going to delete out the 0. Actually turn it on so we can watch it move. And the command we type in here is bbox. So B-B-O-X. Then we're going to add our parentheses. I then need to tell it what object are we looking at. What object are we going to look at for that bounding box to move up? Let's see. And we can use... So we're going to do, and we do that by, we're going to put quotes, .. and then we find that node. And do you remember what node we used? Single support. So haha, it's coming back. That's why we did this, is so that we know we can find the bounding box of this thing and we know how tall it is. So since we named it real nice, we start typing in single and it pops up right here. Do you see this? Otherwise, we'd have to find poly extrude 1. And when you start getting a really deep node, like you're going to forget which poly extrude is what and what does where, and hey, where is it actually finished off? But by doing the single support, I'm actually going to backslash off that. We don't need that. And I'm going to end it with the double quote. It's very easy to find, specifically for doing these bounding box things. These bounding box things are your friends for moving things around in relation to each other. So we're saying, hey, bounding box of this single support object, comma, we need the y. And we tell it by doing this, it's going to be capital D underscore y size. This is all in caps. And then I do the closing parentheses and hit enter. And you see how it moved up? Because this is going to be based on the height of our supports. In fact, if we go back to C and we change our support height, our road height goes with it because the bounding box on that support's changing. Isn't that neat? I think it's really cool. It's all connected and neat. Okay, road's done. We don't actually have to do much more with this road because it is what it is. So it would be nice to start to see our road together with our, move this down here, with our supports. So I'm trying to make this a little bit nicer. There we go. And we're just going to do that with a merge. So I'm going to kind of keep these lined up together, and then I'm going to put a merge down. And with this merge, we can then feed in our copy to points for all of those supports, as well as our road up. And then if we click on here, it's all together. So we have our supports and we have our road. And just like before, once we're kind of at a really good spot where we might need to deal with this later on, I'm going to drop down another null. And I'm going to call this one, not null one, bridge base. So if I need to find stuff about this later, I can find stuff about this later. I can really find like where this is there. So ta-da! We have our supports, we have our bridge. If we're thinking of these kind of like I-beams, it might be better to make this bridge a little bit wider. Let's see. It'll look a little bit more like actually a bridge. Maybe these aren't I-beams, maybe they're more of like big cement structures or something like that. You can kind of use your imagination. The one downside, and it was something we haven't fixed yet, and this is what I'm going to come back and I'm going to fix this later, is do you see how the I-beams or these beams, like it looks kind of weird because they should be kind of pushed over and flush. Like the first one should be pushed over, the last one should be pushed over. Like if we even have more, like it would look better if this was kind of lined up. And yes, I am aware of this. I'm going to show you how to fix this later. It's not complex, but I kind of like to kind of keep moving forward and then introduce like a new little concept with that in order to fix that. So yes, I'm aware. That's why I left this big space here, because we're going to do stuff here to fix that. But we will be returning to that later. I should probably just name this support. There we go. Questions so far? We're doing good? Trying to figure out if I want to take a break or not. The next step is to do the supports. Do you guys want a break? Yes or no? Well, you're not supposed to be following along. That's the whole point, is you're supposed to just be watching and then you go back and watch this later. Do we want to take a break or do you want to keep going forward? No one has any strong opinions? If you don't have any strong opinions, I'll just keep going. Okay. Okay. I'm the one doing all the talking, so I know sometimes like this brain stuff, it's like you got to kind of like, wait, what's going on? Oh, sometimes it can be a little bit. Um, okay, so the next step we're going to work on is making those supports of, we need like a base, we need our top, and then our rails in between this. So we're going to first start off, let me pull up my notes, sorry. This is going to be a much bigger little system over here, so we do have to give ourselves some room. And the first thing we're going to do is we're going to make our rails, we're going to start with the rail supports, and we're just going to make one support. And we're going to do this by first creating a grid. It's kind of what they call planes in this system. So I'm going to put down, a grid isn't a grid. What you think of like a grid is actually a plane. So I'm going to put this here and turn it on. And this is way too big for what we need. We're actually going to put the size down at like 0.05, 0.05. And rows and columns, it just needs to be a 2 by 2. So we're just making this tiny little plane. That's going to be one support. Those are like the vertical supports on here. And we should probably name this better, just since it is our first node. We're going to call this rail support profile. And that is going to be where we start off with. Next, we're going to be able to control the size of this through our scale. Remember, I was talking about, hey, we're actually going to scale this to change how big we want our rail support to be. So this is just going to be a transform. So I'm going to drop down a transform node. And we're controlling this by C. So we just need to come back over to our C node, find our rail support thickness. I'm going to copy this, and I'm going to come back to transform, and we are going to paste this in our uniform scale. So I'm going to delete out the 1, and I'm going to paste in our relative reference. Remember, I set this one, you can't go past 1 because we're scaling it, so we don't want to accidentally scale it in like a negative direction. So now if we scale this up and down, we can see that we're getting a change in our thickness of this. Ta-da! Hooray! Okay. Next, we need to extrude it so that we can get the height of it. So this is just going to be another poly extrude. I'm actually going to move this C over closer because I'm going to be using it a lot. I don't want to have to zoom in and out. So the C is going to be kind of traveling along with me since I need to reference it so much. Poly extrude. Connect that up. This one is also controlled by C, if you remember, because we need to change the height based on whatever the user puts in. This one, the directions kind of demo it this way, so I'm going to kind of show you that this is also possible too. So the height, rail height, 1 makes more sense, but honestly, like a 1 is going to be way too big for our road. It's going to look kind of really weird. So I'm going to copy this like I normally have been doing. And let me go back to poly extrude and turn on all my settings correctly. Rather than, actually I don't need those. Rather than just translating it like this, let me paste this in. This is going to be way too big to deal with anything bridge related. But like we don't really want to work in too small decimal. Maybe you do want to go back and like refine it down to decimals. But something that we could do is we could, on the front of this, to control this a little bit better, is we can say, actually we can put on the end, we're going to multiply this by 0.25 so that it's going to kind of, only take a quarter of that. We've done stuff similar in like programming for like Unity. Remember, like when we do like, especially like movement or like jumping power, sometimes we'll like multiply things by like decimals to kind of like is either too strong or too weak. Like we can multiply like a big number or a small number. So you can always control things this way. So don't think when you paste these relative references in that that's it. I'm multiplying that relative reference by 0.25 just so it's a little bit more reasonable of a number for our rail height. And that is it for our singular one. The next thing we would want to do then with the single one is we're going to have to copy it, you know, along very similar to our supports, but we're going to be copying it along the length rather than the width. So we can't use that same kind of method. But we also want to be, you know, we're thinking kind of procedurally where we need to put the rail top and the rail bottom. We need to create those. It's a little bit different than the other ones. So why don't we use, you know, we're going to use a slightly different method of this where we're actually going to start creating our top and bottom as well, and then use those to duplicate this along. So we're going to make a new grid over here, and that's going to be the profile of our rail, like you'd actually like go along the width. So this is the vertical one. We're going to start making the horizontal ones. So I'm going to make a new grid. This is going to be called rail base profile. And this one is going to be kind of similar to the other one where we actually need to flip this. For one thing, the rows and columns should be 2 and 2, but we need it to be kind of sideways. We don't want it to be flat. We're going to actually change it to the XY plane so that it's turned on the side correctly. As far as the size goes, we can just, this is where we could control it. Like we could start setting up controls so that it's related to the poly extrude. I don't want to go into that quite yet because it's, you know, a little bit tad more complicated. Not crazy, but I would save that for later. Let's just set our size to a 0.1 by 0.1 so that it's something a little bit more reasonable, and we can come back and visit this later. The next step is going to be to do our poly extrude so that we can get it the length, and we're just going to put that node down. I feel kind of like a broken record, but again, this is being controlled by our C, so we don't have to set this up correctly. We do need to cap these all, and we can come back to our C, and this is going to be our length. Let's copy parameter and come back to our poly extrude, and we are going to do that on the Z. So I'm going to paste that into here. And now we have our first base rail, you know, kind of down, it's down there. We'll eventually need an upper one, but we're going to take a slight break from this so that we can work on putting our lost train of thought. We're going to take a break from doing the top and bottom, so that because we're going to utilize this to place our rail supports along it first. So let's see. Let me just make sure I do. So we're going to put that on hold for a second. Let's see. I feel like I missed a step. Oh, okay, yeah, okay. So taking a break from actually creating the top and bottom length rails, and we're going to utilize this node we're going to kind of branch off of it and do some other things to actually place our supports. First things first, we do want to control how many rails we get, and we're doing that in C with our rail frequency. So we're going to come back here. We're going to copy this parameter, And we're going to come back to our poly extrude, and we can go to our divisions. It's at the top right here. So rather than one division, which would just give us one rail ultimately, I'm going to delete out that one and paste in that relative reference for our rail frequency. And if we turn on, nope, let's go back to C, and let's actually just bump this up. We can see it's now controlling how many divisions we have. So if we want 4 divisions, 1, 2, 3, 4, we're going to end up putting our supports in the middle of all of those. Because it's going to be a neat way that the support's actually going to go in the middle of each of these polygons as a way to kind of balance this out. So let's see. So let's go back to the poly extrude. So we're controlling the divisions with that rail freak. We're controlling the length with the length. Now we're going to do something. It was really interesting in the demo, and they're like, hey, this is a really neat trick on how to do this kind of stuff. So what we're ultimately going to do, I'm going to explain it first, and I'm going to do the steps, is we are going to isolate these top polygons. We're then going to delete out anything that's not those top polygons. We're going to convert those to circles, because when we convert them to circles, what happens is rather than a primitive, it'll be a circle here, and it puts a point right in the center. We can then grab all of those just individual points and do a copy to point with those things to those center points. So it's really neat how this works. Like, it's a real kind of like a trick of how to move things to the center of other polygons. It's neat. So first things first, is very similar to how we've been doing things, where we need to first make a group of the polygons we want to work with. And we're going to use a slightly different node. And if you built your object the same way as me, it's going to work the same way. And because we can't tell it what the top primitives are, because if we change the amount of rails we use, it's going to change what primitives are selected. So we're going to use a node called group by range. And we're going to put this under here. And the way that this works, it's a way to select things using a pattern. So, oops, no, I'm sorry, I put this on the wrong one. It needs to go underneath this one. Sorry about that. So we need to put this on the rail. And what we want to do is we want to select these top polys, and only those top polys. So this is the group by range. If we turn on polygon numbers, where is that one? This one. It does follow a pattern. So notice it's 4, 8, 12, 16. So 0 and 1 are your end pieces, and then it kind of goes around, and it's always going to be named the same. So we can use that pattern to just make sure that we're selecting the top one. So if you built this exactly the same way as me, you're going to be able to set this up the same way. Otherwise, you might have to tweak some of the numbers. So first things first, we're making a group, so we need to name our group. I'm going to name this group top prims, top underscore prims, so that it's easy to find. I'm going to make sure I also name this node that, so that we can find this easy too. And now we have to set up what the pattern is. The group type is going to stay primitives. We are going to start, where's our lowest polygon? It's polygon number 4. So we're going to start at polygon 4. And notice as I slide this up, it stops, things start to get deselected. So we're going to start on 4. If your lowest polygon was a different number, like if you forgot to put on end caps, it might be a 3 or a 2, so you'd want to start on those numbers, but we want it capped, so we're starting at 4. And we're going to set at 0, which just means that it's going to just go on forever. So, if we keep it on 0, it means we're not going to ever stop, because we don't know how big this is going to be. What if it's a really long one with a lot of divisions? We then select one of, and then I'm going to bump this up to 4. and it's just going to, do it every 4. So we start with 4, and then it's going to add 4, add 4, add 4, add 4, and it's just going to kind of keep going on. So this is a really neat way to select your top polygons when we don't know how many polygons they're going to be. Like, we can't do the selection like we did with the last type of selection. So this will procedurally do our selection no matter how far we want to do. So that's all set. We know which ones we're going to select. We now want to delete all of the polygons that we don't have selected. So we're going to use a delete node, hook this up, and we're going to say, we're going to select our top prims group. And we're going to say, let's see, do you notice how it deleted them? We don't want to delete selected, we want to delete non-selected. So it's going to delete everything that we did not have, that isn't in that group. So we made our group, then we're selecting that group, but we're saying delete not that group. And we're good to go. The next step is going to be to turn these into circles. I know this is like really weird, this is like a really weird thing, but this is, I guess, like a neat tip for like, hey, this is a Houdini kind of thing. Like, this is a way to approach this. So I thought it was kind of neat. And we're just going to use a convert node. And we are going to say we're going to convert our group, those top prims. We want to, we don't need to do a group for this one, sorry, since it's whatever's left. We're going, I'm sorry, I'm clicking on the wrong ones. We do need to group, I clicked on the wrong node in my notes. We do need to say top prims. We're going to group these. We're going to say convert to circle. And you see how now they're all turned into like these circle objects? That's all we needed for that one. Because what's going to happen next is we're going to do another, let's see if we can do our convert. I'll make sure I'm doing it correctly. We're going to do an add underneath this. So we're going to get our circles. We just want to add points to these circles. We're going to say number of points is 1, and we're going to delete geometry but keep the points. And now we have like these kind of points just kind of floating into space. So let me kind of go over it again real quick. And it was kind of weird, but I was told this is a really like neat like little snippet of how to work with Houdini if you need to put something in the middle of a polygon. First, we just isolate those top polygons. We isolate the polygons that we want to move things to the center of. We then delete everything but those polygons. We then convert them to circles, and then we use this add node to put a point. It puts a point in the middle of those circles, so it's the exact middle of the polygons that we ultimately are working with, and deleting out everything but those points. All we need to do after this then is do our copy to points. So I'm going to add a copy to points. We are moving it to those points, and we're moving these poly extrudes to those points. So now we have, let me turn these off, them all duplicated along that length. And if we come back to C, rail frequency, we can adjust that, and it's going to automatically figure out where those need to go. We can change the length of our road, and it will automatically space those out. So now we don't have to go in there and figure that all out, because that's would be really frustrating if we're modeling this by hand. We're going to let the computer do that for us. So let me move this over a little bit. So rails, vertical stuff, all done. The next thing we would need to work on after this would be, and let's see, let me be good, and I'm going to add a null on the end of this. Since we kind of did like a bunch, just would be, we might need to reference this later. I'm going to call this one rail supports. So if we need to do something later, we can reference that if we're at this state. Okay, let's see. So we got that. The next step is going to be to go back and rework on our top and bottom rails. So we got the bottom one done, right? There it is. We just need a top one. And we can just do this by duplicating this and moving it. So I'm going to make a copy node. And I'm going to feed this poly extrude into here. And we can just, it's a copy and transform, so we can just move it in the same one. We don't have to put another transform. That's why it's copy and transform. Where do we need to move this one to? We need to move this one to the top of our rails, right? So guess what we're going to use? A bounding box. So we named that rail supports, so we can easily find the top of that bounding box. We just need to do bbox in our Y. What are we looking at the bounding box of? / our rail supports. Close quotes, comma, we need the D underscore Y size for that. And I'm going to tell you, and we can always come back in and fix this later, but I know this based on, from like working through this already, is we're going to see the supports kind of sticking through the top of this. So we need to move it, not just the bounding box, but just like also the height of our rail as well. And I did hard code this in, so we would have to possibly come in and fix this later. But for now, I'm just going to do a plus 0.1 because I know that's how tall my rails are. So it'll be not kind of sticking out the top of that. So hey, we got our 2. All we need to do now is we have our first one. So let's move this like this. We have our second one. We have our rail supports. We now need to just merge these all together. So I'm going to make another merge. We are going to merge in our rail supports. I'll turn this one on so we can watch it all go in. We have our base one. And we have our top one. See how it fixed that? If I go back here and I take out that 0.1, I don't like that. So just plus 0.1, and then it kind of bumped it up. We could control that a little bit cleaner. Maybe we'll come back and see if we'll do it. I'll see how much time we have. I don't want to run out of time. We could also possibly move these supports up a little bit because they are also inside, I think. Is that the way that they're working? I think they might be actually inside of there too. So it would probably be good to also do a transform and move those rails up. That wouldn't be too hard. Actually, let's do that real quick. I'm going to come underneath rail supports. I'm going to add a transform node. Oops. Transform. I'm going to stick that in there. I'm going to name this one better. I'm just going to call this one lower rail or something like that. And I'm just going to transform this on the Y, B box, dot dot slash, what did I name that? I totally forgot. This is why it's better to work that. Rail, lower rail, that's what I called it. That's why those null nodes are handy. Lower rail. We want, and I never remember these either. Let's see. dy size, that's what it is. d underscore y size. There we go. So we bumped that up a little bit. Now if we go back to our merge. Oh, that was way too tall. What did I mess up? Hold on. Maybe I'm getting a little too far ahead of myself. Maybe I should move this. I think I'm going to go back and undo that. I think I didn't plan this one out well enough. So let me just take out that node. See, it's fun to experiment. We'll just live with it. I think it's moving it based on the size and not the actual location. So I'd have to go back and poke at that a little bit stronger and get the location versus the size. But I don't want to spend time on that. But hey, we did an experiment, didn't quite work. We're going to keep moving forward, and we can always go back and fix it and mess with it later. Okay, so we have our one rail. Let's see. Just want to make sure we got rail that. We then now need to get our second rail. Let me make sure I'm doing this right. Merge. We need to do a copy after this. So I'm going to add a copy node, copy and transform. We do need to we do need to be able to work with these individually. So we're actually going to use an output group prefix so that we can reference rail 0 and rail 1, so we can keep 0 where it needs to be, and move, we have to move one up and the other one up and over. So turning on output group prefixes will let us be able to do that. The next step is going to be to actually start moving things around. I'm going to not translate anything in this one. Instead, we're going to do them individually. The first one we're going to move up and over. So I'm going to make a new transform node. And we want to move this one. First, we can move it up, and we need to move it to the bridge, the bridge base. We need to move it up to the top. So it's another B box for this one. It's going to go in the Y, and I kind of have it kind of pre-written out a little bit just to kind of help with time, but it's just going to be B box to the bridge base, the D Y max, and it's going to move upwards so that it will be on top of our bridge. This one we also want to move over as well, and we want to move it over on the X so that we're over all the way as well. So we are going to do another B box. So the Y goes in the Y, the X goes in the X, where it's going to be the bridge base, but D X max. And it should fly all the way over to the end of our bridge. And it looks kind of weird now because we can't see our bridge. If we kind of toggle it on and off. Actually, I can. Yeah, so there's our bridge. And we can see it's all the way over there. And it's going to have a little bit of funkiness to it, but that's fine. We're going to fix that in a previous step. We just need to move the other one now. So we're going to do, oh, I'm sorry, I forgot a step. It's moving both of them, but we only want to move one of them. So that's where, if you remember, I said, hey, output group prefix, turn this on, and we just left it the default copy group. If I go here and go up to group, I can choose copy group 0 or copy group 1. And if I just do copy group 0, it's just going to move that one, the first one, from that copy over instead of both of them, because we're specifying which one we want to move. We do need to move this one upwards, and so we are going to add another transform. But this one is just going to be copy group 1. We only need to move that one up. Same idea. It's actually going to use the same bounding box as copy 2. I'm sorry, transform 2. For that the Y. Because all we have to do is move it upwards. Everything else is we don't have to move it anything on the X. So it's just going upwards onto that bridge. So I'm going to come back here, go to translate, paste that into there. Put in the wrong axes, the Y axis. There we go. And we have it moved upwards. Last thing that we want to do with this set is with our rails, is we do want to make a nice null out of this so that we can reference it later if we need to. So I'm going to make a new null. I'm going to put it down, and we are going to name this one rails. All right, so now we have our rails, and let me kind of organize this a little bit. Let me move the C over here. We have our rails. We have our base bridge. We just need to merge these together. So I'm going to make another merge. Put it here. I'm going to turn it on. We're going to first merge our bridge base, and then we're going to merge our rails in. And then we will put a last null out for our finished bridge. So I'm going to discuss the big issue if you're looking like, oh no, but that thing's not correct. That's the thing I'm going to go back and talk about. So outbridge. And hey, it looks pretty good, and we can test our controls. We can change the length, and that all adjusts. We can change the width, and that all adjusts. We can change our support heights, like maybe we have really big support heights. Number of columns, we can adjust that. The road height, we can make it a big road. The rail support thickness, we can adjust that, as well as the rail frequency. Okay, so the big issue, I'm sure you're looking at this and you're like, oh man, but that looks really weird. One, these supports aren't in the, they're sticking out, and that's weird. Two, the way that we set this up, this one looks good because of the way we built it. We can just move it upwards and it's on there. But this one is sticking out because remember we used the bounding box of the bridge. We could solve this by using the bounding box of the road instead. That would easily fix this problem. If you didn't want to fix the supports, like maybe you wanted the supports sticking out here, we could get the bounding box of the bridge object and just use its X max instead of the whole bridge X max. That would solve that. In fact, let's do that. Let's fix that one first. That's an easy one to fix. So we're going to go back to where we made our bridge, which was here. But maybe we should just add an extra null. I'm sorry, our road. And we're just going to add this, and we're just going to call this one road. And now we can easily reference this. It's just the road. So let me turn this one back on. Rather than moving this transform 2 to the bridge base for that X, we're going to move it instead to the X, not the, yeah. Instead of bridge base, we can change this to road, to that null node we just made. And you see how it pops back over there. So that's an easy one to fix. If we wanted to go back and do it that way. Okay, so because if you look at the homework, I'm doing it, I kind of did it in little pieces because the homework is kind of like the same as this week where it's based off of like what you get done. You can fix that. So like doing that C null node is completely filled out with the appropriate ranges. The single support is generated. The support duplicate across the width. Support offset fixed on ends. So fixing, what I'm going to show next is like a whole 10 points in itself. So if you don't get to it, that's fine. But you should at least get that rail fixed. Rail system placed on both sides. So make sure that you do get that fixed to get the whole thing of this one set up. So, you know, we thought we had it the right way, but we went in and made an adjustment. The last thing I do want to demo is fixing this issue, because that bothers me. Maybe your bridge would be like that for some reason. Maybe they're going to be side by side and you could just duplicate it over and it's meant to be like that. Who knows? My bridge is not meant to be like that. So we're actually going to go back in and make our fixes in right here where we were doing like the width and stuff like that and duplicating them across. Okay, so what we're going to do is we're going to add in a node here called attribute. We're going to make an attribute create node. Attribute, if I can type it correct, attribute create. And what this is going to allow us to do is we're going to make a new attribute. Let me feed this into here. Never remember how to break these. I guess we'll do that later. And this way we will be able to reference the dots coming out of the line so that we will be able to then find those and specifically move the first one and then the last one. So we're just adding a new attribute to our items. In fact, let me just make sure I'm going to show you this the correct way. So let's see. Oops, sorry. Actually, I'll show it. I'll show it this way. Let me go through the process, and I'll go back and explain what I did. Oh no, I lost myself. Hold on. I'm going to go through the process. I'm going to explain what I did towards the after I put in my nodes, so that I'll explain how it works. So we're adding the attribute create, which means that we can give things certain names and be able to access them later. And we are only going to add one attribute, and the name of the attribute we're going to name it support. So as we generate our different supports, like when we copy them to our nodes, it'll have like that support attribute so that we can find that specific support, support 0 would be the first one and move it to a specific space, and support the last one and move it to a specific space. We'll be able to fix this. So down here, the value that we want to give it is we're going to say at, like the ampersand, ptnum, so that the value of our support attribute is just the point number from this line. Let's see. We do want to make this an integer because it's just going to be like 0, 1, 2, 3, 4, etc., etc. And let's see, that's all we have to set up for the attributes. So now these, this line, all those points on there, have an attribute called support, and it'll give the value for that support attribute. In fact, if we go to our geometry spreadsheet, we can see we have a new, if we go back to this one, it's just that line. It has all these points on there, and they're, you know, right now it has 4 points on there with their positions. And this is just this geometry spreadsheet up here. This is how I got here. Once we go add the attribute, we're adding a custom attribute to here. We're saying, hey, that support attribute, all it is whatever number, whatever the point number is for that point, it's the same, so that we can access this later. If you go into the geometry spreadsheet and you want to go back to your scene view, it's just going over here and clicking on scene view. So what are we going to do with this? We're going to feed this now into our copy to points. We actually don't need that line anymore. Now we have like this nice little thing right here. And then, you know, still the same, but after we copy them to the points, we want to move the first one over, and then we want to move the last one over. So this is just going to be a transform. So I'm going to add a transform node in there. Maybe, let's see, give myself a little bit of space. Things get so crowded. Let's move this down. And don't worry about this. It's just kind of weird because some things have that attribute that we just made and some things don't. So if you see that, it's fine. Don't worry about it, okay? Transform, what are we moving? We want to move the group. We're going to look at, for the support, at support equals 0. So whatever is associated with the 0, that support attribute, whatever is associated with the 0 value, which was first that point, but we copied the support we copied to that support point 0 now has that attribute of support 0. We're going to just move that one. It's going to be this one. Where do we want to move it? We want to move it over by half of a support. So we're going to say translate it bbox of our, remember we did that single support. Thankfully we did that. We want to get the X size, so D X size. And we're going to divide that by 2 because we only want to move it half. So like right now you see it sitting in the middle. We don't want to move it over a full size. Just, you know, we just need to move it half of its size over. Let's see. What did I do? bbox. Let me make sure I did this correctly. It didn't move. Hold on. One second. Something broke. I must have missed a step. Hold on. Sorry. Let me double check. I think I missed one. Give me 1 second. I think I forgot to click on something. Give me 1 second. I forgot a step. Let me pause the video. I forgot that since that support thing is based on having points, the group type, it's not guess from group, we need to turn it to points. So the group for this first one is at support equals 0, because we want to move that very first support. Change the group type to points. And then afterwards, we're just going to use the bounding box of a single support divided by 2, because we only have to move it halfway. And then it'll kind of slide it over that little half amount. So that was that issue. Sorry about that. I forgot group type has to be set to points. We just need to move the last one now, and then we'll be done. So if we go to, let's see, we need to move, I'm going to call this one transform first call. We're going to add another transform in there. Call it transform last call. And this one we have to be a little bit trickier. The first one was easy because we know which support. It was the 0 support, right? We need to know which one is the last support, which isn't, it changes. It depends on what our column number is, right? What that C column number. So we're going to first start off with the group is at support equals, and this is where we would normally put in 0. Instead, we are actually going to reference this. We're going to get the number of columns. I'm going to copy this parameter. I'm going to come back into that transform last call, and on the end of this, I'm going to paste that in. Paste relative reference. So it does have to be in parentheses. Oops, no. I'm going to put it in parentheses just in case. Because, so column number. Let's say we have 4 in there, and because we want 4 columns. This is going to give us column, it's going to say at support equals 4. But if you remember, our first column was support equals 0, because it's kind of like in programming when you use something like an array, the first element's always 0. Same kind of concept with this one. So we can't just say like, hey, there's 4 columns, so the last one's going to be number 4, or whatever is being stored in there. We do need to come back into here and say, get that number, but minus it by 1. So like, SG113 is coming back. When you're working with elements, it starts at 0, and the last one's always the number minus 1. So don't forget that, or you're going to run into problems. So we got that. The last thing now is we do, we're selecting this object here with that, but we do need to move it. So the first one, we moved it half of a bounding box of that support forward. This one's sticking out the other way, so we need to move it half of a bounding box backwards. So we're actually going to do negative B box, so we can slide it the other way. Our single support, oops, and we want to do the D, we want to find the X size, D X size, and then we're going to divide that by 2 because we only need to move it half of a size backwards. And let's see. Oops, I did it again. Guess from group, I gotta change that to points. And then do you see it kind of squish in? That is how you fix that issue. And I know that's a little bit, do you see how it's, so nicely lined up now. Nicely lined up, good to go. And those rails look good. We can, all of our stuff is now controlled by our C. And we have a nice modular bridge. One thing I did not fix, and maybe I'll leave it up like, hey, if you get this completed and you want a challenge, I'm not going to give you points for it, but I think I've talked long enough. This is almost like a 2-hour-long demo. This issue here, where these, you know, we should control these based on the shape of these so that it gets bigger and smaller based on the size. The hint I'll give you is you would use a bounding box again, just for, you know, we could easily set that up. But I think I've talked long enough. So if you do want to go back in and fix that issue, that's something I did not cover, but you should be able to based on what I've shown. So, ta-da, modular bridge. Questions and comments. What do you guys think of this one? Any questions? How about comments? Is this an interesting thing, or did I just completely bore everyone? A lot to take in. Let's see. Alex thinks it's cool. It's useful. Yeah. The reason I liked this particular one is if you want to kind of keep going with Houdini, is this is a really great introduction to how you have to think about construction. The use of these null nodes is like super important to control these things, and like those copy and pasting of relative references is really important and kind of like a super fundamental idea. So that's why I kind of stuck with it with this one. To kind of emphasize this. We didn't do any kind of unwrapping this time. I thought it would be better just to kind of focus on really trying to construct something from in a similar way that you would construct something in like Maya. Yeah, and I've seen some people make crazy things with these kind of concepts. Like you can make a whole like building system. You know, we did a bridge, but you could also do like think of like townhouses, like, oh, you can control how many heights and like how tall the roof is and how many windows and randomly place, what are those things called? Oh, shoot, greebles on things based on something or other, you know, in pipes. Like this is like the beginnings of how to do procedural modeling with this stuff. So let me turn off the recording if there's no questions.